It is said that the human eye has receptors that are only sensitive to 3 areas of the visible spectrum of light, these being the low, medium, and high frequencies of electromagnetic waves, which are supposedly what light is composed of. Where the low frequency enters the eye, the low receptors are stimulated and we are said to perceive the color red. Where the medium frequency enters the eye, we perceive the color green, and where the high frequency enters, we see blue. But what about the rest of the color spectrum? Well, according to this theory, when wavelengths of an amplitude falling between, say, low and medium enter the eye, both low and medium receptors in the eye are simultaneously stimulated. Faced with this conflicting information, the brain is said to perceive the color yellow. In exactly the same way, wavelengths falling between high and medium entering the eye, both high and medium receptors in the eye are stimulated and we see light blue or cyan. And so here we have what seems as an explanation as to why, when red light and green light are mixed, we perceive yellow. For the red and green light together simultaneously stimulate both low and medium receptors in our eye, and our brain is left with no choice but to perceive yellow. However, what about magenta? Unlike yellow and cyan, magenta doesn't have a corresponding wavelength of its own. There is no magenta wavelength. So magenta is explained as being the combination of both long wavelengths and short wavelengths entering the eye. Now, because magenta doesn't have a wavelength of its own, the conclusion, according to this theory, is that the human brain makes up the color magenta. Now, this conclusion demonstrates, in my opinion, a lack of critical thinking. Clearly, color doesn't exist anywhere outside of our perception. As we have just seen, all the colors arise only once the information from the eye is processed by the brain. To then explain magenta as being made up by the brain is, at best, a completely empty statement. The only consistent conclusion to draw from all this is that color is not wavelengths of electromagnetism, and to confuse the two just ends up as nonsense. Normally we feel we have explained a phenomenon when we have reduced it to its parts and demonstrated how these parts interrelate and fit together. A house, for example, is a pile of bricks arranged in a precise order. If we explain the order of the bricks, we have explained the house. But the reverse of this is also true. A pile of bricks, arranged in a specific order, would make no sense unless we first knew what a house was. The totality house is then not just a sum of its parts, it is a whole unto itself, and is, ontologically speaking, just as valid as the bricks it is made out of. It was in this spirit that Goethe refrained from explaining light in terms of something else, and instead sought to view the phenomenon in its essential totality. When he found the essence of a phenomenon, he stopped himself from looking behind it. Instead, he accepted that this essential manifestation was the most basic and primal form the phenomenon could take. He called it the Ur-phenomenon, or primal phenomenon. When playing around with a prism, Goethe quickly noticed that color is only ever found where areas of light and dark interact with each other. This observation made him strongly disagree with the Newtonian theory, which stated that light contained the color within it all along. Convinced that both light and dark are required for color to arise, Goethe set out to find the most basic instance of this fact. He discovered that the red of the setting sun and the blue of the sky were both phenomena belonging to the same law. With the setting sun, the atmosphere acts as darkness across the light source. But against the pitch-black darkness of space, the atmosphere now acts as lightness across the darkness. He formulated the law as follows. Darkness across light gives a red-yellow color. Light across darkness, blue-violet. This law explained for him the fact that the dark mountains in the distance appeared blue, whilst their snow-capped peaks would contain a reddish hue. From Goethe's point of view, Newton's spectrum of colour appeared as a contrived effect of the more primal law governing colour. He observed that the green only occurred when the yellow and blue were brought together and overlapped. Seeing nature as a self-contained totality, Goethe knew there must be a corresponding polarity to Newton's spectrum. Indeed, he found such a polarity. To show it, we place a thin shadow in front of the prism. Where Newton's spectrum is formed when yellow and blue overlap, Goethe's is formed when violet and red overlap. We can now bring the two spectra together and present colour as a self-contained whole. There is another surprise to Newton's experiment. When the beam of light shining through the prism is projected on a screen, the blue-violet are on this side of the beam and the red-yellow on this side. Yet when the observer looks back through the prism, the colours are switched. Remembering Goethe's law governing the colour of the sky and the setting sun, we should not be surprised by this. Colour is all about the dynamic relationship between light and dark. In this configuration, the prism shifts the beam of light in this direction, meaning on this side, the light area is shifted across the dark area. Light across dark means blue-violet. On this side, the dark is shifted across the light area. Dark across light, red-yellow. When the light and dark borders are viewed through the prism, however, the shift now takes place in this direction. The colours blue-violet and red-yellow now switch places. Of course, someone will be quick to point out that the shift of this image doesn't actually take place in physical space. Rather, it is a projection of the observer's vision. Yet here's precisely the key point to the Goethean approach to science. Colour is a quality of our perception. We can't describe redness by weighing or measuring it. As the issue here is the orientation of colour, we are hence dealing with a qualitative phenomenon. Why should it surprise us, then, if both images are governed by the same laws? Goethe's method treats nature as a totality. It is thus a gateway towards a science that doesn't reduce nature down to abstract mathematical entities. As such, Goethe's explanations don't take the form that science is accustomed to them taking. Due to this, many criticisms have been levelled against Goethe's insights into light and colour, namely, that they are scientifically irrelevant. No doubt we'll have everyone explaining to us the real reason why the sky is blue and how light is actually just waves of little tiny particles shooting about the place. Yet, for Goethe, reducing a primary phenomenon to something else by imagining other phenomena behind it is a childish way of understanding nature. Quote, "The highest which man can attain in these matters is astonishment. If the primary phenomena bring him this, let him be satisfied, and forbear to seek above or behind, for here is the limit." But people will not stop here. They are like children who, after peeping into the mirror, turn it around to see what's on the other side.